Hello, GEOG1112 TA. This is the introductory lab. I'll be going over what we'll be needing to measure with our equipment. So this is Arts of Humanity 405, all good and ready. We have our maps and our data sheets for the students. So as you can see here, we have 4 different weather devices. We have a weather meter, we have an infrared thermometer, we have a solar power meter, and a CO2 meter. And I will show you a brief demonstration on how to use each one for the introductory lab. So I'm gonna come over here, table. So you can see I have the sheets here. You can see there is one of these boxes on every table. And inside each box, you will find the equipment for this introductory lab, which we will be doing. So I'm gonna open one of these up. So this is everything. This is how each container will look on the inside. The first tool I will demonstrate will be the Kestrel weather meter, which will be used to take our wind speed, our relative humidity, our dew point temperature, and I believe our altitude as well. This is it here. It's a green machine. You can see it spinning already, so it's very sensitive. So I'm going to press the on button here. As you can see, wind speed. So just blow into it a little bit. You can see it measures the wind speed. So the students from their locations will be able to measure the wind speed and write that down on their sheet of paper for all the teams, but it does more than that. If I hit this button here, oops. Yeah, so it's the air temperature, the wind chill, which unfortunately, well, maybe fortunately, this time of year in Georgia, we won't be using wind chill because that's more of a wintertime measurement, below 40 degrees or 45 degrees, and you'll only find that within the confines of a refrigerator this time of year in Georgia, so we won't be using that. Relative humidity, 60.5%, so this is what the students will be writing down. If we were taking the measurements in here, we'll be doing that outside. The wet bulb thermometer, so like the dew point temperature as well. So yeah, and the barometric pressure, so that's the air pressure, and the altitude. So this is how high we are above sea level, and as you can see, that is in feet, not meters. So keep that in mind. So yeah, that's the first tool. Probably the most important one because that's where most of the measurements will be coming from. But after that, we have our infrared thermometer. So I'm going to open up here. Oops, sorry. Right here. This is the infrared thermometer. This is how that looks. Be sure, this is very important, be sure to let your students know that this is a laser and it is not to be pointed at one another, or especially not at their eyes, because they could do damage and we do not want anyone getting hurt. So please, please, please let your students know that this is an actual laser, and do not point it at each other. It is used, you want to point it at non-living things, at surfaces to measure temperature. Do not point it at one another. So to turn it on, I'm going to hit the red button here so I can scan. So I'm just going to measure the temperature of this table. It's coming up about 18 degrees centigrade. That shows centigrade, but we can change it to Fahrenheit. and this is about 65 degrees Fahrenheit. As for our paper, our temperatures are going to be in centigrade. So you see air temperature and surface temperature. So air temperature will be taken with the Kestrel thermometer, and surface temperature, which needs to be in centigrade. Oops, I put that in centigrade. Will be need to be taken with this infrared thermometer. So that's what that is. I'm going to put that away. We're going to move over to the solar power meter, which will be in this black container. So this reads the solar energy in, let's see here, watts per meter squared. And you can see right now it's reading 0.0. That's because I'm inside the classroom. But outside, obviously you'll have a bigger number here. I think, so this is in BTU. So we're gonna change the, oh, there we go. So now we're in watts per meter squared. That's where we wanna be. Make sure all of your students are aware that their measurements need to be taken in watts per meter squared so they won't have to come inside and do unnecessary calculations. So please be sure of that. Oh, we got a little reading there. Yeah, 0.7. So it'll obviously be much higher if you come out and it's a sunny day on the outside. So that is our solar power meter. Turn that off. Yeah. Okay. And our last device. Very nice container here. This is our CO2 meter. It will be used to measure carbon dioxide concentration in the air. So, and that will be, by the way, in parts per million. So just know that for your students. So with this one, and if you read the introductory lab on the Climate Literacy Lab's website, it'll tell you about this. Some of the locations for your students will be like parking deck. Let them know that they need to go to the top of the parking deck. They need to be on the top level where they have clear and open air around them, so they can get the best readings. And if they're going to the Woodruff Park location near the water, they can get as close to water without dropping it in. So get them close, but not, too close where it's dangerous. And that's really for everything. So for this, I'm gonna turn this on. I believe there's a 30-second warm-up period, so. And after this period, we will be able to see our carbon dioxide concentration, hopefully in parts per million, so we won't have to do any crazy calculations. And then we will write that down on the paper, or at least the students will, do their assignment, and then you'll be ready to move on to the next part of the introductory labs, which will involve a little bit of Google Earth and some Excel, but that can be done with the computers. All right, what do we have here? CO2, 501 parts per million. Man, I hope that's because I'm just sitting here talking, because that's pretty high. That's really, it's not great. But yeah, you're getting different numbers outside. So that's what that is. You can see the concentration, parts per million. So yeah, that's it. As you can see, that's all. Let me turn that off. That's all of our equipment here. And when you're finished, just make sure you're able to put everything, turn everything off, and place everything back in their proper containers so we're not losing them, so the next class can use this without any difficulty. So definitely it is your responsibility to make sure that all the tools and equipment are returned to their unique boxes and containers and are left the way they were before you got into the classroom. So please make sure the students, are careful with the equipment turn that off. And get everything back in there. Let's close it like so. And that's it. We're done.